This video explains the Import Group box under the Start ribbon, which contains options to import various data sources. The Import Group box features the following buttons: Import Data, Import Static Scans, Import Trajectory and Point Clouds, Import Measurements of Total Stations, Import Points from Text File. In contrast to Import Static Scans, data is accessed or retrieved via project files opposed to individual point clouds. The following information can be imported under Import Data: PointCab project file, ZNF project file, Faro Scene, Riegl project file, points from LupoScan, groups from LupoScan, Scantra projects from versions 2 and 3, scan sequences, import existing registrations and vertical axes. Two prerequisites need to be fulfilled before this functionality can be used. At first, PointCab's LSD SDK library needs to be installed on your computer. A link to the most current version can be found on our homepage. The second requirement is that a PointCab license can be accessed. Once the aforementioned necessities are satisfied, a PointCab project file with the suffix PCP can be accessed. This allows importing scans, station groups, pre-orientations, vertical axes, as well as local and global point coordinates into Scantra. Note that Z and F laser control users can optionally use a special distribution of Scantra that operates directly under laser control. This distribution allows for reading from and writing to Scantra project databases under the control of laser control. Import and export functions are disabled in Scantra as laser control performs these tasks. The standalone distribution of Scantra also offers the option of importing Z and F laser control projects. In this case, stations, station groups, pre-orientations, vertical axes, cloud-to-cloud registrations, local and global point coordinates, as well as defined relations between scans, are imported. Note that single scans with the suffix ZFS can individually be imported under Import Static Scans. Proprietary data from Faro scanners can be imported in two different ways. The preferred method can be found in the Import Data Group box and requires a Faro Scene project with the suffix LSPROJ. It requires the installations of the Scene API standalone package and the Microsoft Visual C++ redistributable package. In case these cannot be found on the processing unit, both can be downloaded from our homepage. To access a Faro Scene project, navigate to Connect to Scene Project under the Faro Scene entry. This will start the Faro Scene API as a separate process, which is accessed via inter-process communication. An additional window will appear in the Windows taskbar called Scantra Scene Interface. Do not close this window during processing a scene project. Scans, including grouping and point coordinates, can be imported from the project. The scene project only needs to be accessed for operations that access the point clouds directly, such as detection and export, or to import points or targets that were detected in scene. For all other operations, the scene project can be closed using the disconnect from scene project function. A new scene project can also be created in Scantra by adding raw or previously processed Faro scans with the FLS suffix. In order to achieve this, navigate to the Faro Scene entry and click at Create Scene Project. Then add your scans to the project by clicking at Add Scans to Scene Project. Should raw files be added to the project, use the filter function of Windows to display all unprocessed FLS files that are located in a folder with exact same name as the files. Type *.fls, which will list all desired files within the folder that contains the scans. Then add the scans of interest to the project by selecting them from the list. Proprietary data from Riegl scanners can be imported in two different ways. The first method can be found in the Import Data Group box and requires a LupoScan Pro project with the suffix RSP. To access such a project, navigate to Import Riegl Project File and select a project of interest. When importing a LupoScan Pro project file, stations including station groups, pre-orientations, vertical axes, and local point coordinates and project coordinates are transferred. LupoScan's file structure does not use an explicit project file. Instead, information about group associations and digitized points are provided by additional files that refer to individual scans. LupoScan point clouds of static scans have a LPS suffix and need to be imported first under Import Static Scans in the Import Group box. Points can be imported under Import Points from LupoScan. Files with the suffix lps.ori contain points that were digitized in the scanner's local coordinate system. Files with the suffix ref contain geodetic reference points. Local and global points with identical identifiers were already matched in LupoScan and hence can be matched in Scantra by using this information. Groups can be associated to individual scans by importing ini files under groups from LupoScan. In contrast to Scantra, individual scans can be associated to several groups in LupoScan. Hence, Scantra will associate a scan to the first referenced group in the INI file. This functionality is designed for users who want to import already completed projects or projects that are composed by individual parts into a new Scantra project. This can be achieved by navigating to the entry Scantra projects from versions 2 and 3 under Import Data. Using this function imports all entries from one database to the other. Given the case that identical group names are being used in different projects that contain different scans, all scans are imported into one group. Bitmaps from projects that are potentially stored at different locations are being copied into the directory of the current project. This function allows to import already decomposed scan sequences either from the kinematic module or from dot product scanners, where point clouds are represented by individual frames. Given the case that existing registrations or vertical axes have not been imported, for instance, due to mistakenly false settings, this can be achieved in retrospect by using the entry Existing Registrations and Vertical Axes under Import Data. After its selection, a dialog appears in which a user can choose to import either existing registrations, vertical axes, or both. This information can be retrieved from single scans or from supported project files. Should scans be selected in the graphics windows, this function will only be executed for these. Individual static scans can be imported using the Import Static Scans button. In addition to adding the point clouds to a project, pre-orientations and vertical axes can also be imported. In order to do this, navigate to the Import ribbon in the Settings and choose the desired information. Scantra can import the following formats: ASTM, E57, Z and F, ZFS, Faro, FLS, ASPRS, LAS or LAZ, LupoScan, LPS, PointCab, LSD, Riegl, RDBX, OpenScan Tools, TLS, and like a Geosystem, PTX. As soon as this button is clicked, the import dialog opens and scans can be selected. Per default, a dialog appears where the user specifies if pre-orientations and/or vertical axes should be imported. This dialog appears as a reminder in case a user has forgotten to choose the appropriate settings before importing data and can be deactivated. Subsequently, the unscaled relationship graph is then opened and the stations are arranged in a grid if there is no pre-orientation. Pre-orientations can originate from registrations of other software or from scanners with integrated sensors such as GNSS sensors, inertial measurement units, or compasses. Note that the option Fix Vertical Axes is a special case for E57 files and has to be used if the vertical readings were already applied to the point clouds yielding in leveled scans. The reason for this option is that E57 does not explicitly store vertical readings, for instance, from a compensator. Hence, Scantra cannot distinguish cases where no vertical readings are given or if rotations about the X and Y eyes were already applied. Importing FLS files directly requires the installation of the discontinued Faro LS library, which can be found on our homepage. We recommended using the Scene project import under Import Data instead for the following reasons. The newer Faro Scene API is much faster. It allows updating the Scene project after registration in Scantra, and points and cluster associations are transferred from the Scene project. If this button is clicked, the interface navigates to the Kinematics ribbon and opens two consecutive dialogues. The first allows to assign a trajectory file, while the second one is used to select the corresponding point cloud. Please note that the format of the trajectory file must first be selected in the settings. The following trajectory formats can be defined: ZNF FlexScan, GeoSlam Faro Orbis, PLY, as well as three ASCII formats with frequently occurring sequences of the individual parameters. The following point cloud formats can be imported: LAZ or LAS, E57, PLY, and TXT. The optional polar module allows importing raw polar observations from total stations. After clicking on the Import Measurements from Total Stations button, the following formats can be selected: Leica GSI, Leica HEXML, Trimble JXL, Technet Betan Neptan, and a vendor-neutral polar format. After selecting the file, the data is displayed in a preview table and can be changed if necessary. This button opens the point import dialog and allows to import superior or local point coordinates, including individual standard deviations, into an existing Scantra project. Superior coordinates are typically observed by geodetic sensors such as total stations, GNSS, or leveling, and are associated to the global coordinate system. Local coordinates, for instance target centers or natural points, were determined in other software and are associated to the local coordinate system of a particular scan. Note that local coordinates to any number of scans can be imported at once. The dialog contains the three group boxes: type of file, column definition, default values, as well as other components that will be explained in the following. At first, a coordinate file must be selected in the dialog window. The first line of the file appears, which can then be defined and read in column by column. The user can choose to decompose individual lines and associate them to individual attributes by using fixed column width and position or by deploying definable separators. In the first variant, the user can semi-automatically select the corresponding areas in the top line and accept the positions using the Select Columns button. For the second strategy for file decomposition, various separators can be defined for the CSV import. Should a line contain certain characters or punctuation marks that should not be imported, the delimiter text box can be used to define them. The association of X, Y, and Z values are mandatory. Additional values such as system ID, point ID, and the standard deviations are optional and can be selected if available. The four latter entries assign accuracies to individual points, which serve as weights within the block adjustment. This can be either done in 3D, sigma p, or by assigning individual coordinate components in X, Y, or Z direction. In the default values group box, the coordinate system ID for all points can be defined, and a prefix can be added before the point ID. It is also possible to assign the identical standard deviations to all imported points. Standard deviations of 0 mean that the values from the options dialog are used for the relevant coordinates. In the comment marks field, characters can be entered that mark comment lines. These comment lines are ignored during import. After successful import, point coordinates can be found in the project tree by opening the according station or in Point Coordinates browser.